Alrighty, welcome back everybody. It's your main math man, Mr. Shen, coming to you live from Summit at Castro. In this video, we're going to be talking about some residuals, which kind of looks like a scatter plot. We will work with the line of best fit, and we'll kind of talk about that statistical analysis. Again, these lessons are really mathy, so make sure that you're hearing and seeing every detail. So, in the intro, you compared how far the three friends were from a particular place. I'm skipping over that just because it doesn't have really what we need for it, but it was just kind of talking about, how far they are from a certain restaurants, and then which one would be the best option because they are, basically the same the restaurant is the same distance from everybody. So it says you can apply the same concept to a scatter plot with a line of best fit. The vertical distance between a data point and the line is called a residual. Just like the friends chose the restaurant that was best for all of them, we can use residuals to find the line that best fits the data points. So let's look at the example scatter plot, to the left, which shows on 6 colleges that Kelly is interested in. Kelly looked up the acceptance rate and average students grant aid for each college. Use the graph to answer the following question. So, what is the average student grant aid for the school that admits 10% of the students and estimate based on the data point? So what I could do, I can look at the percent admitted on the x-axis and the average student grant aid in thousands. So again, this is, you got to remember too, these numbers are not $40. It's like 40,000, 50,000, 60,000. So let's find where it's at. So I'm going to find 10%, which is this line right here. And I'm saying, okay, approximately, since it's the average, we're going to say it's about where the data is, or where the actual point is. So notice how this point right here is just below the 50,000. And what we're going to actually, we're going to say y is approximately, or y is equal to 49,000. Then for number 2, it says, what does Kelly's line of best fit predict the average student grant aid will be for a school that admits 10% of students? Estimate based on the graph or by using the equation for the line of best fit. So what you can do is you can, approximate. You can say, okay, well, look at that line. That line of best fit helps you predict answers. So it's using the data that you have so far, and it's making a projection to be shown, how much student aid. So, as you go to the right, it goes down. So this is going to be a negative slope. So that's why we look at this equation right here. And this little symbol right here is considered hat. So let me label that as well. This little symbol right here. It's almost like an arrow right above the Y. We're going to say that's going to be hat. So for example, I would call that Y. I would call that Y hat. So that is just the approximate equation for that line. And then what we can do is, we can, estimate it and say, I think it's maybe around 43,000, but in math or 42,000 maybe, but in math we can get our definitive answer. So what I'm going to do is I'm going to take that x value, which we plug in as 10%, because that's what we're using on the x-axis. So I plug in that value for x, and then I solve, and I get 42.3. But I have to remember, it's not $42.30. That is 42.3 thousand, which is the same as 42,300. So our value, or our prediction, and let me make sure it's a y hat, because we're saying, that's the prediction amount, is going to be 42,300. Then it says for number 3, what is the difference between those two values? So what we can do is this. Again, let's take the approximate value that we have for that. Again, this is just approximate values. So this was the actual value, and we're just using the 2 approximate values that we had. So we have 49,000 minus 42,000 is equal to 70,000. So that's going to be the difference between those two. So we're looking at the point compared to the line. That difference between the two is going to be 7,000. So the value that you just found is the residual. So that's 7,000 right here. We're going to label that. I can label this as R, which is the residual. And we're going to say you may also hear it be called an error when looking at data representing an entire population. The residuals for a line of best fit can always add up to 0. So they're supposed to cancel out. So that gives you a little formula there. So the residual is equal to the actual value minus the predicted value. And you got to be careful because sometimes you might get a R value that is negative, and that's okay. So we're taking whatever the actual value is, meaning the actual data point that we have on our graph compared to the line of best fit that is trying to predict, our overall values. So that remaining amount is that residual. All right, so let's talk about a graph here. So this is the sticker price and the student to faculty ratio. And so that colon in the middle just stands for 2, but it's just, comparing those two variables as a ratio or a fraction. When choosing in college, one factor you might consider is student to faculty ratio. This ratio tells you how many faculty members there are compared to the number of students. A lower student to faculty ratio might mean smaller class sizes, more opportunities to talk to professors, and more individualized support. So the student to faculty ratio for Summit is going to be, a smaller number as well, because we have a lower student count, but we have, about the same amount of faculty compared to other schools. So that just means, you should be able to get more support, and you have smaller class sizes. So make sure yeah. All right. So it says the scatter plot on the left shows the data on the sticker price and the student to faculty ratio for a representative sample of 27 four-year U.S. colleges. So it says sketch that line of best fit, or sketch the line that you think best fits the data to the left. So I already went ahead and kind of sketched it. I also looked up an old video. I was going to show it to you, but it's a really, really old video on my YouTube channel. And what I did was, when we worked with 8th grade line of best fit, it's an approximation. It's not going to be perfect, it's not going to be great, but what we can do is, usually when you graph your line of best fit and you're just kind of eyeballing it, what you can do is you could say, hey, I try to have an equal amount of values above and below the line. And you can kind of show, hey, it has a slight negative slope, and it's not going to be perfect, and it can go through the points, but it doesn't have to go through the points. And so, you can have something approximately like that. And then for number 2, it says, based on your line of best fit, what is the residual at x equals 60? So let's go to x equals 60, and I can say, okay, well, that value that we have here is about 6. It's not quite in the middle, but it's just above it, and our line is going to be above it like this. And I actually want to move that up just a little bit, like here. So what I'm going to say is this. I'm going to say, if you take our data point minus our predicted value, which is our line of best fit, we're going to say it's going to be 6 minus 9, which is equal to -3, and that's going to be, that's going to be equal to our residual, which is labeled as R. Then for number 3, it says describe the correlation between the sticker price and the student faculty ratio. And remember, try to think about it. Consider, is it strong or weak, positive or negative? So we could say is the correlation is a weak negative linear correlation. So what that means is, as you are looking from left to right, it is going down like the line shows. Again, it's a linear correlation because it makes a straight line. So then in number 4 now, it says compare your line with your classmates. How do you think we can figure out which line are best possible fit? So if you want to try to sketch your own, that's okay. But what we could also do is, as we get a list of approximate data points, type them in Desmos and calculate a line of best fit, which I'm actually going to show you how to do later on in the lesson. But Well, make sure you can, get a list of data points, which is otherwise known as a table of points. And also, too, just to make sure we're covering this as well, for number 3, it says that linear correlation. I said about the, it makes a straight line. I'm not talking about the data points. I'm talking about the line of best fit is a straight line. Because what you could also do is you could have different types of lines that, fit your data. So it could be a quadratic equation. It could be an exponential equation. You have many options with that. So it just depends on your line of best fit. So next part now, it says the ordinary least squares regression. So you can also think of it as least squares regression. So it says the residuals are part of finding the line of best fit. That process is called ordinary least squares regression, or OLS regression. Figures out which line is the best fit by finding the line that minimizes the sum of the squared residuals. So let's see how OLS regression works for our data on sticker price and student to faculty ratio. So it says the graph on the left shows the residuals for all of the data points. The graph on the right squares each of those residuals, and then the best fit line makes the total area of those squares as small as possible. So it's taking the values from the left and it's squaring them to the right. So it says which data point has the residual with the greatest vertical distance. So you can approximate the distance. You can approximate the coordinates. So what we're going to say is this. It says this is the same data for both sides, but what we could say is this. We could say the point 26, 2 is the greatest distance, and that makes sense too because if you look at this data point right here, this is the value I'm talking about, or you could talk about this data point right here, compared to the other values of the residual. We could say that, hey, that negative 12 is going to be the largest amount. So we're saying, the x value is 26, the y value is 2 to get that point. Then for number 2, it says the residuals for this model all add up to 0. How is that possible if the line does not perfectly fit all the points? So what we could say is the negative and positive numbers, let me say numbers, plural, cancel each other out. Then for B, it says in the intro, we squared the distances from the restaurant for 2 reasons. Because both options added up to the same sum, and number 2, because we wanted to account for one person living far away. How can we approach how can that approach be applied to the line of best fit? So we're going to say this. We're going to say the line of best fit always has residuals that sum to 0, meaning they add up to 0. By squaring these distances, we get more information. We also weight the outliers more heavily, and that's because the squared value is very large for the points that are far from the line. Make sure there's nothing else I want to say about that. Okay. Then moving on to number 3. So it gives you some options there, but it says the equation for this regression line is y hat equals negative 0.16 x plus 18. Which of the following statements about the slope is correct? And what we're going to say is actually that first one. We're going to say that the slope is, again, make sure you're seeing when you have y equals mx plus b, that is the slope intercept form. So we did that in middle school. We applied it in 9th grade to some data points. Same kind of thing. We're able to figure out what that slope means. So we're going to say the slope is negative 0.16. This means the predicted student to faculty ratio decreases by 0.16 for every additional $1,000 in tuition. And that's just being able to read the graph specifically. Then for number 4, it said the average annual sticker price for a 4-year college has increased by approximately $10,000 since 2000, adjusted for inflation. Do you think that has caused a corresponding decrease in the average student to faculty ratio over the same period of time? Why or why not? So I'm going to give you 3 options. Mister, there's so many things to write. I'm going to give you 3 options, and you only have to pick one. So, out of these 3 options, please pick one. So we could say, no, we do not know what increasing sticker price causes a decrease in the student to faculty ratio. You could say, no, we do not know what factors drove the increase in the cost of college. Or you could say, yes, hiring more faculty could be one factor that increased college costs. So pick one of those 3 options. You do not have to write all 3. All right, so now let's apply it here, but I want to make sure you're remembering. I think I have there's a Desmos activity with this as well, so if you want to try that out, please let me know. We can talk about some lines of best fit. But it says, remember, one way we can measure how well a model fits the data is by looking at the R-squared value. R-squared is a number between 0 and 1 that tells you how well the model can predict the data points. A high R-squared value means the points are close to the line. So that's the main takeaway from that point, is that sentence at the end there. And the reason why it's a takeaway is because when we go to apply it, and remember, these are test questions. Which of the following statements is true for a line of best fit with a high R-squared value? So you're taking your residual and you're squaring them using that OLS method. So for this, a couple things we could say, but we're mainly going to say, if we're looking for that high R value, we're going to say the data points, fall close to that line. Then for number 2, this is where we have to get a little bit mathy, but we can say this. All right. It says the graph below plots the relationship between U.S. university costs and student aid. Use the graph and the data provided in the table to complete parts A through D. So it gives you a scatter plot in the graph. Again, on your x-axis, it has the average tuition and fees. And then on the y-axis, it has the average student loans. And then what you can see as well, the most important part from it is being able to see, those data points in there specifically are labeled in your table. So what you could do is I'm actually going to take these points and put them into Desmos. All right, so in Desmos, what you can do is this. I'm going to take, let me show you what I'm going to do here. You're going to take and you're going to use the values that are in this table. Again, you want to make sure that you're labeling them with X and Y. So I'll do a couple examples and then I'll skip until I have all of them. So for example, I would say I make an ordered pair first. And let me make sure I'll use them here. There it is. Okay. So yeah, for example, I would say, 4,100 is my X value, and my Y value is going to be 6,875. And what I can do, I don't see it on there, and that's okay, but what I can do is this. I can say edit list. So I'm going to click the little gear in the top. Again, please make sure you do this with me so that way you can see how this works. But I'm going to click edit list, and I'm going to click convert to table. So now it's a little bit better to do as well, so that way I can, have those points. And what I can also do is something that I learned recently is if I get stuck and I like on my graph, I don't see where my graph is, what you can do on the side here is that if you graph out that point, you can actually click zoom fit and it will go to that point. So that way your point is directly in there. And what we're going to do later as well is I'm actually going to click that again so that way I can fit all those values in there. But what I'm going to do is I'm going to continue. I'm going to say, I have X is 4,325, and I have my Y value is 7,125, and I'm going to continue with those points. But the key part to it, though, is this. I'll continue those points in a second here. Again, I can click zoom to fit as well. So notice how it will automatically adjust the values in there, so that way your points are on your graph and visible for your graph. But what we have to do when we're doing line of best fit, a key part is this. You want to make sure that you change this X and this Y. You need to change them to be a specific value. So what you are a specific character. So what you do is you're going to say, you're going to do shift minus. So notice how my cursor drops down. I have to do shift minus, and I'm going to put 1, and I'm going to do shift minus and put 1 on both of them. Because of what that's going to do is it's going to help me get my line of best fit, which we'll see in a second. So what I'm going to do is I'm going to put these points in to the graph, so that way we have them. And I just realized that you weren't able to see it, so that's what it looks like. So let me repeat one more time. I just realized that you weren't able to see it. So I click home. So a couple things that I did. I graphed. Let me start from the top here. I typed in 4,100, and I did 6875. And what I can do is I click the gear at the top. Make sure you can see it. Yep. Okay, this time you can see it. I click the gear at the top. I click convert to table. It will make a table. I can click zoom to fit, and it will take me to that point. And I can click shift minus to do the correct table. But for this one, what I'm going to do is I'm going to give you guys this one, so that way you guys see exactly what it looks like, and that way you can use it for the test question as well. So that way, the main part I want you guys to be able to do is make the equation for this. So again, I click that zoom to fit for my graph. All right, so let me type in these points. All right, so on this problem, I typed in the values from your table, and what you can do with those values is we can make that line of best fit. So the graph doesn't look exactly, like how it does on our picture, but that's okay as long as these values are correct. Again, we can click zoom to fit to make it a little bit different too. You can also, if you don't like that, I can also change exactly what it is. So for example, I can set up my x-axis to be from 4,000. So I'm just taking this from the actual graph. I'm going to say 4,000 to 6,500. That's a step of 500. And then for my y-axis, it's going to be 6,500 to 7,500, and the step is 250. So I'm getting these values from the actual question on the page. Again, if you look at your window here or your picture, I'm getting those values. So I said on the x-axis it's counted by 500s, on the y-axis counting by 250, and so I can do that as well. I can also put the labels in there, but it's not that important. But however you want to do it, the main thing you need to do is you want to look at the data and make sure the data is in there. But the key part is make sure that you have those values in the actual correct columns. So you want to make sure you put shift minus and then put a 1 here, so that way you do it. Okay. So now that we have our data points in, let's take a second to breathe here, make sure that we are seeing the graph as well. So we have our data points in there, but on part A it says use a graphic calculator, that just means Desmos, to determine the line of best fit for the scatter plot represented by the graph and table above. So instead of coming up with just a rough sketch where we eyeball it, we're going to be awesome mathematicians and we're going to come up with an exact answer here. So what we could do is this. In your calculator, this is the important equation and main equation you want to take away from this lesson. So it looks like this. I'm going to say y. I do shift minus to get 1 again, and it's going to say, hey, those are your y values in there. That's good. But I'm going to say y sub 1, and the key value that you have to use here is you have to use tilde, which is the approximate. So I'm going to do shift, and then I'm going to hit the key that's to the left of 1. So that's going to be shift and then to the left of 1. I think it might be on the keyboard as well. Yeah, you can also hit it on the keyboard. So if you click on the little keypad that's down here, you click keypad, click ABC, and it's going to be this right here. You can also click that. So I'm going to put approximately that, and then I have mx sub 1, and then plus b. So if you notice, that's going to be compared to, it's very similar to our slope-intercept form that we're used to making. And this is very helpful because now this is the information that we need. So notice how it says regression parameters. It gives us our slope, it gives us our y-intercept, and it gives us our statistics for it. So it gives us our r-squared value, and it gives us our r value. So this is exactly what we need for our line of best fit. So now let me write some of these values in here, and we're going to say that and actually let me take this first. So what I can do from this is I need to round my answers as well. I think that's part of the directions, or at least they round somewhere here. Hold on, let me see. Yeah, so on the, let's say on the slope, so again, what you can do is it has it defined for you. So it tells you what m is, and what I can do is I could say round parentheses m comma 2, because I need to get 2 decimal places, and so that's going to be my value for m, and then my value for b is just a whole number. So I'm going to say round parentheses b comma 0. Let me make sure it's on here, so that way you guys see it. So these are the 2 values. I would write this down if I was you. I would say make sure that you have those 2 values written out. So I got that from our equation, and then I'm rounding those 2 values because this is going to help me write my equation. All right, so let me switch back here, and I'm going to say my equation here is going to be y equals negative 0.15 plus 7,631. And then the other key takeaway as well from that you need is we're going to say that r value is going to be negative 0.8621. And what you can do to get that value, let me show you on Desmos as well. Same kind of thing. Let's say I wanted to round comma 4. Again, I can leave those all in there, but I'm going to say round r, and I can take this value. Actually, it gives you the value already from here, but I can also paste it here in case I needed it. I can say round comma 4, and it will round it to that decimal place. So it's already rounded for you to 4 decimal places, but just make sure you have it in there. All right, so now let's move to part B on here. So for part B, it says identify the slope and y-intercept of the line of best fit, round those values to the nearest hundredth, which is what we did. And it says, what does the slope and y-intercept mean in the context of the situation? So a couple different things here. Again, make sure you're seeing, we said our, let me actually write this here as well. For the key part for this, you want to make sure you're writing this. We're going to say y1 and tilde, that little squiggly line, and we're going to say mx1 plus b. So make sure that this is the key equation or the key thing that you have to be able to type in for your table. Again, your table of values, you would say this is x1 and this is y1. So just make sure you're seeing how to set that up. All right, once you have that, again, you can round those values very carefully. So again, we'd say round, just making sure you guys have this, we'd say round m comma 2, and we would say round b comma 0. All right, so some things that we want to say about this is as follows. Yes, we do need to write all this because we have to be very specific about what we're saying. So the slope, which is equal to m, is the same as negative 0.15, and then this means that as the cost of attending a university increase, the amount of federal student loans awarded decreases. Specifically, for every additional dollar of tuition and fees, the amount of student loans is reduced by 15 cents. Then the y-intercept, which is equal to b, is the same as 7,631 and 30 cents. The y-intercept does not not really make sense in this situation, but it would mean that if a university's tuition and fees are $0, the amount of student loans would be $7,631.30. I think they're getting that from the dollar amount. So let me show you on Desmos. they're getting that from this value here. So if you wanted to round comma 2, you certainly could. In the answer, it has that it's rounded comma 0, so it's either one that you want to do. Again, in your equation, I would say to just round comma 0. But on here, I'll switch to the last part. So or the part C, I should say. So for part C, it says record the value of the correlation coefficient, which is R, for this relationship. Explain your answer about the correlation between the variables using the vocabulary from a unit. So we're talking about correlation, causation, we're talking about the residual R in our line of best fit. So we found what this value is. Again, use your Desmos calculator to find what that is. But we're going to say R equals negative 0.8621. This would indicate a strong negative correlation between average tuition and fees paid and average federal student loans awarded. The negative sign indicates the relationship is an inverse one. As tuition fees increase, the federal loans decrease. So again, we're noticing too, again, we talked about the values from before. We talked about the correlation coefficient. We said if that value, the absolute value of it, is greater than 0.75, that it's going to be a strong correlation. It's a negative correlation because as it goes to the right, it goes down, which is why our slope is negative. Then for part D, it says Terry looks at the graph and says, well, according to this graph, I better not go to an expensive university because then I won't get any federal student loans. What mistake is Terry making and how can you correct him? So we could say this, we just remember that correlation does not imply causation. The tuition increase does not cause federal student loan awards to go down. Tuition increases do not cause the amount of loans to decrease. Rather, there is likely some other factors that affect both, such as the effect of wealth on accessibility of expensive schools and decrease needed for student loans. So yes, you do need to have a solid response to that. Make sure that you are copying down all those parts. All right, so a bunch of parts of that. Make sure you're asking questions as they come up for that. And then for the last one, for number 3, it says Henry collected data on the percent of applicants admitted and the median ACT score for 24 colleges. Here are the results from his linear regression. So it says y hat is equal to negative 0.13 plus 33.23, and then his R squared value is going to be 0.49. So Henry plotted the data out on the point, came up with a line of best fit, and then for part A, it says describe the relationship between the percent of applications admitted and the ACT midpoint. So we're going to say this, we're going to say there is a moderate negative correlation between the percent of applicants admitted and the ACT midpoint. As the percent of students admitted increases, the ACT midpoint decreases. So we're just talking about, as you look at the line, and it's not a strong one exactly because our R squared value is not high enough. But what we can say is that there is a negative correlation because it goes down to the right. Then for part B, it says the University of Colorado at Boulder has an acceptance rate of 80.7%. According to the reports, the median ACT score is between 27 and 32. How does this compare to the median ACT score that would be predicted by the linear regression equation? So what we can do is this, we can take that value, plug it into our calculator. So we're going to say y equals negative 0.13 times 0.87, which is let's say 0.087, I should say. And we're going to add 33.23 to it, and we get our value here. And so we're comparing it to those median scores. And so once we get that value, we can say from the equation, the median ACT score would be approximately 23 for a school that admits 80.7% of applicants. So we rounded up there to get an approximate score. It says the actual median at CU Boulder is significantly higher than the predicted value. And then for part C, it says, do you think Henry's line is a good model for the data set? Why or why not? We're going to say yes, the R squared value is moderate, which is 0.49, indicating that the points are fairly close to the line. There are no noticeable outliers. The points seem to scattered around the line fairly randomly. There is not a clear nonlinear pattern, meaning not a straight line. And then the line may not be a good fit for all the data in the set, such as CU Boulder, which is kind of like an outlier, but overall it is a fairly good model. So just make sure that you're seeing those parts for each of those. Make sure you're asking questions as they come up, and as always, super slam that subscribe button.